dad, mom, sister, baby, brother, rover. Does McDonald's sell cheeseburgers? Dead mice smell bad. Dracula must suck blood. Hi, I'm Sarah Korsnalik, and today we're talking about the 5th grade standard, NSO.2.2, which asks students to divide numbers of up to 5 digits by 2-digit numbers. The mnemonics at the start of the video may be how many of you learned how to perform long division, or even how some of you still teach the steps in a division algorithm. I first want to stress here that the beauty of mathematics is that there are many ways to approach solving a problem. And I'm not here to argue for eliminating these mnemonics, at least for today. However, if using these phrases is the only way you teach long division to students, I hope that by watching this video, I can arouse some interest and curiosity in you today for other approaches, ones that might develop students into mathematicians who can think critically and problem solve. The 5th grade standard calls for students to learn how to divide, including the standard algorithm. However, remember that multiple strategies should be taught to students, and with any strategy, they should understand the mathematics behind the steps. Students who memorize steps have nothing to fall back on if they forget. Today, our focus is to examine how we can marry the concrete and the abstract when teaching students how to use a standard algorithm for division. Let's look at an example of me solving 4,271 divided by 20 and justifying and connecting my steps with drawings. You would want students to use physical manipulatives at first, but I'm using drawings for the sake of this video today.
Okay, so we are going to look at an example of how to help students with the division algorithm or the abstract and combine it with the representational or the model. So I'm going to show 2 different ways here. So over here we're going to have the algorithm or the abstract, and then over here we're going to have our drawn model. And you'll want students to kind of do these side by side like I'm doing and explain their steps and their thinking as they go. And asking questions as they go is important as well. So we have 4,271 divided by 20, and you'll want to make sure that students know that what they're doing here. So you're finding 20 times something, which is going to go here, which is our answer, is going to equal 4,271. So the first thing you want to have them do is represent this number in using the drawings of the place value blocks. Now, the thousands is obviously you don't want them spending, 3 hours drawing this, because that's not the point. So you can, look, that one's not even great. You can just have them draw a square like the hundreds chart and then write a TH inside to represent thousands if that's a little bit easier for you. Or you can kind of cut these out even and have them just put them next to their drawing. All right, so we have 4,200s, and then 70, 3, 4, 5, 6, 7, and 1. Okay, so we're finding 20 times something is going to give us this number. So there's a few different ways you can think about this, because multiplication is, you can do 20 times something or something times 20. In this one, I'm going to be trying to make groups of 20. So in the first example, we're going to start up here with our thousands. So I have 4,000, so this is where I'm getting that. So you want students to kind of make that connection. So I'm trying to think of something times 20 equals that 4,000, but we're talking about thousands, so it's really 4. So as you can see, I can't make any groups of thousands to equal just 4,000, because I need 20 of them and I only have 4. So that's going to be a 0. That's where that 0 is going to come from. And then we're going to go to the next place value. So now we're going to combine as we go to the 100. So I have 4,200s, which is seen right here. but now I have a mix, right? So how many hundreds are in 1,000? So you have 10 hundreds. So you can kind of write that here, or have students even trade them out, or make another drawing. That will be up to you. So now I have 10, 20, 30, 40, 41, 42. Okay, so that matches over here. So now I'm thinking of something times 20 is going to give me my 42 hundreds. Okay, now I can do something here. So this problem is one that's good to start with, or one similar, because the multiplication equations that students need to understand can be more easily done than, say, if you had 14 here or something. So I can make two groups of 20 and then no more. So I can make two groups. 20 times the 2 is giving me 40, and I can check 10, 20, 30, 40. And then how many do I have left? I have 2 left over. Okay. All right, so now we're moving on to the tens. So now I have how many tens, and we're going to include those 200s. So again, this is 10 and 10. So I have 10, 20, 21, 22, 23, 24, 25, 26, 27. Well, I only have a 2 here, so where's that 7 coming from? Oh, well, it's coming from here. So that's where we're getting that 27 from. So now something times 20 equals 27. Well, we know that we can only make one group. There it is. And then we're going to have these 7 left over. So one group, 7 left over. Go on to the next step. Now I have my 7 ones, or my 7 tens, which is equal to 70. So 10, 20, 30, 40, 50, 60, 70 plus the 1. That's where that 1 is coming from. And then something times 20 equals 71. So they can possibly count by 20s or make a picture, or use repeated addition. So 20, 40, 60. So I can make 3 groups. 1, 2, 3, which is 60. And then I will have right there my 11 left over. So you'll want to have them, you can have them write it as a remainder 11, but also writing it as the fraction as well. So that is the first way to solve. And now we're going to take a look at the second way to solve, which is thinking about it as partial quotients, which again, no easier, no harder, just depends on the students. So you can show them these different ways to have them see what works best for them. So I'm going to represent it the same way. I just used the TH there so you can see how that works. All right, so now we're going to go kind of step by step, but instead of like up here when we used the digit, right? We used the digit 4,000s divided by 20. Now we're using the actual value of the digit. So I have 4,000 here, and I'm trying to see how many groups of 20 I can make. So again, this problem is a little bit simpler to start with because the students should come with this background knowledge. Not saying they will, but you know, you can easily kind of walk them through this if they don't understand how to solve this. So we know that that is 200. I'm just gonna skip ahead with walking them through that just for the sake of the video. So up here, you're gonna keep track of your partial quotients, and then down here, your what's left over. So because we chose this problem that divides easily at the beginning, we've used all of these, which is 4,000, and we have our 271 left, right? So now the hundreds, we have 200 divided by 20. So again, that's a little bit simpler. So we know that's 10. Subtract, we get that 71 left. You can see that right here as they're working. Now we have here, we have 70. We're going to make groups of 20, and they can divide them out, and they'll get 3. They'll have 11 left, and again, they can kind of do one of those to show that there's 11 left, and 11 divided by 20. We can't make a group of 20, so that is represented just as the fraction. And here is our partial quotient answer. So 200 plus 10 plus 3 is 213, and then you either have remainder 11 or 11/20. And those are your two different options. And there's more than that, but those are your two options you can start with.
Now that you've watched the video, think of all the foundational knowledge a student needs to learn and have accessible in order to master this skill successfully. There's a lot going on, from subtraction to place value to basic facts. 5th grade is when it's all coming together. Students need time to learn the standard algorithm and genuinely understand the steps involved. At the start, you may want to consider teaching this in a small group setting rather than whole group, in order to ensure that students are explaining their thinking and using the manipulatives or drawings to justify. Also, remember quality over quantity. You may consider only going through one example or maybe two in the first lesson with students to be sure that they can explain and understand each of the steps. It's also helpful to stop frequently to give students time to ask questions of you and each other. Check out the resource page that accompanies this video for more tips and resources on teaching the standard. Moreover, please be patient and understanding with yourselves. As I said, a lot is involved in teaching just this one standard. Oftentimes, schedules only block off a week at best for teaching this standard, which is most likely not going to be enough. Students may need all year to practice this standard and arrive at a place of true understanding. Keep this in mind if you test students using end-of-unit assessments. Remind them, and yourselves, continually of students' growth in order to help foster a growth mindset environment in the classroom. Until next time, thanks for listening.